welcome to the conversation. My name is Lisa and I'll be your host in today's show. We also have Jared, our resident astronomer, and we have Space Mike, our rocket specialist, and we also have a Dada producing this show. Now, today in space news, we have
a satellite that was long thought dead has returned from the grave.
And the space station's new faulty hand has been fixed, and cosmonauts also go on a record-breaking spacewalk.
And we also have an interview with Gilmour Space Technology. Stay tuned. This is tomorrow, Orbit 11.05.
Good morning. How's everything up in the sky?
And welcome. We also want to give a huge shout out to our Escape Velocity citizens of tomorrow that help crowdfund these shows. These are the people that give us $10 per episode on Patreon or $30 per month on Minds.com. They get access to our exclusive behind the scenes Discord channel and a host of all other really cool rewards. So if you would like to help and crowdfund the shows of tomorrow as well, head on over to patreon.com or makersupport.com/TMRO. Now, we always like to start off this show with some launches. So, Space Mike, what did we miss in the last week? What happened?
Before we get started on the launches from the last week, in case you guys are wondering, unfortunately, Carrie Ann is sick this week, so Lisa was kind enough to step in and host for us this week. Thank you very much, Lisa, for being here. And so this week, we want to talk about quite a few things that are going on at SpaceX. And this past week, SpaceX launched a Falcon 9 rocket that launched a military-grade communications satellite for SES and the Luxembourg government. And this launch happened this past week on January 31st at 21:25 Coordinated Universal Time from Space Launch Complex 40 at Cape Canaveral, Florida.
6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Love that. Just so happens that this rocket was lifting off from Cape Canaveral on the 60th anniversary of the launch of Explorer 1, the first United States satellite. And the Falcon 9 launched a day after SpaceX had scrubbed a countdown to replace a faulty sensor on the Falcon 9's second stage. Pretty lucky coincidence, I think, anyway. The rocket's first stage booster, which was reused from a launch back in May of 2017, shut down and detached from the upper stage and went back for a descent into the Atlantic Ocean as planned. However, even though the first stage booster was outfitted with grid fins and landing legs, there was no drone ship deployed for the booster to land on. This was because SpaceX was testing the effectiveness of a high-thrust landing burn using 3 of its engines instead of just 1. Now, meanwhile, the upper stage, single-engine Merlin upper stage, shut down around 8.5 minutes and then reignited its engine about 18 minutes into flight to place the satellite, which is called GovSat-1, into an elliptical high-altitude super-synchronous transfer orbit that stretches about 36,000 miles or 58,000 kilometers above Earth at its highest point. And then the satellite itself, using its own propulsion, is going to be synchronizing into its final geostationary orbit. Now, owned by Luxembourg, GovSat is a public-private joint venture between SES and the government of Luxembourg, and it's going to offer secure military communication services for Luxembourg, as well as the country's allies in Europe and NATO. Now, apparently, the first stage landing test did go well, and the booster did survive its water landing and was photographed there. And Elon Musk even wrote on Twitter, that's so cool.
Oh boy,
Elon Musk wrote on Twitter, that hopefully the recovery team will be able to tow this first stage back to the port. And I'm curious to see what kind of damage was done to this. But yeah, that's really cool that test was successful and they were able to find it again. So
I just love that, like, they weren't supposed to recover it, and you know, it was just supposed to crash in the ocean and sink to the bottom like every other rocket in history besides Falcon 9 and the shuttle. But this one survived. Like, I think that's incredible. But Mike, there were some more launches, right?
Yes, there were. There were quite a few more launches. Next, we had a Soyuz launch that was carrying 11 Russian, German, and U.S. satellites into orbit. And this was on Thursday, February 1st, from the Vostochny Cosmodrome, and it launched at 2:07 Coordinated Universal Time. This Soyuz 2-1A rocket was fitted with a Fregat upper stage, which was programmed to fire 7 times to deploy its 11 satellites into 2 distinct orbits that were several hundred miles in altitude, and then do a firing burn to break and be able to have a destructive re-entry back into Earth's atmosphere, ensuring that it doesn't create any space junk. Now, the primary payloads on this flight were the Canopus V numbers 3 and 4 Earth observation satellites. The 2 spacecraft, which each weigh about a half a ton, will assist the Russian government in disaster response, mapping, forest fire detection, and resource monitoring. But aside from those 2 primary payloads, there was also 4 Lemur 2 CubeSats that were for the United States Space Spire Global's commercial space network that they're going to hopefully have a commercial communications network with these small CubeSats. And aside from that, there was also 4 nanosatellites for a technical university of Berlin, which are demonstrating S-band inter-satellite communication packages that would allow future constellations of spacecraft to conduct autonomous missions. And there was also a CubeSat for a amateur radio relay called D-Star-1 Phoenix that was developed by German Orbital Systems. And it's interesting because it replaces the D-Star-1 nanosatellite that was launched on a similar flight on the Soyuz that had an error back in November of 28th of last year, which also launched from Vostochny, but unfortunately the payloads were not placed into the correct orbit and quickly fell back to Earth. So it was cool to see that this launch was successful and that those 2 satellites and the secondary payloads were deployed successfully. So congratulations to Roscosmos for that.
Yeah, that's awesome. But there was even more launches, right, Mike?
Yes, there was. And seeming to be a little bit of an irritation to some people, we had another Chinese launch that happened this week that we need to talk about. But this one had a couple of commercial payloads on board, so we got a little bit more media and information from this one. I'm talking about a Long March 2D launch that launched 7 satellites into orbit, including 2 for some Argentina companies, and then 2 others that were for a company that is out of Denmark. We'll get to that in just a minute. So let's go ahead and check out the footage of this, and you'll see what I mean in just a moment here. The primary payload was Zhangheng 1, which is designed to measure seismic signals that could help predict future earthquakes. Now, this Long March 2D launched on Friday, February 2nd at 7:51 Coordinated Universal Time from the Jiuquan Satellite Space Center. And the primary payload is also called the China Seismo-Electromagnetic Satellite, which was developed in partnership with some Italian scientists. Now, there were 6 other payloads, and 2 of them were CubeSats for a company called Gilmour Space from a company that's in Denmark that I mentioned. But there was also 2 others called NewSat 4 and NewSat 5, which are hyperspectral imaging microsatellites owned by Satellogic, the Argentine company. And then there was also 2 CubeSats named FMN1 and Xiaonianxing, which were also launched for Chinese startup companies on this particular launch. So very cool to see another launch, and we're going to hopefully have a competition going on between SpaceX and China to see who launches more rockets this year, and I'm excited to see who wins. But there was also one other launch.
Well, I
what
was going to
that,
say,
Jared?
should we count it as rockets or cores that get launched throughout the year?
Good question. I think we should just count it as total rockets. We'll see.
Sounds good. So.
But we had of course, we're all looking forward to the Falcon Heavy launch, which hopefully will occur this upcoming week. It's been scheduled for February 6th, but, of course, rocketry is hard, and we'll see if it actually goes off on the first scheduled time. But even though the Falcon Heavy is a very, very large rocket that's debuting, there's another rocket that has debuted that has attempted to launch before, but this is a much, 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 much smaller rocket. In fact, it's an upgraded sounding rocket to be able to launch a 3-unit CubeSat into orbit. And this was done by JAXA, the Japanese Aerospace Agency. And there wasn't a whole, well, you'll see. This happened earlier today, actually, Saturday, February 3rd at 5:03 Coordinated Universal Time from the Uchinura Space Center, which is on Japan's southern Kyushu Island. And this is pretty exciting.
2, 1, 0, 1.
This rocket is the SS-520-5, which is a 3-stage solid-fueled rocket, and it's shot, of course, you might have seen that it's shot from a rail launcher there, and JAXA confirmed that the rocket successfully achieved orbit less than 4.5 minutes after liftoff, one of the fastest space shots ever carried out. But not only that, this launch carried a 3-unit CubeSat, which was called TRICOM-1R. And the whole idea behind this is that the whole reason that they're doing this is to get the price down for launching a single 3-unit CubeSat into orbit for less than $500,000. So I think that this is a pretty interesting project. And confirmation that the SS-520-5 successfully reached orbit was provided by JAXA about 3 hours after liftoff. And from the footage that you saw there, all we really saw was the first stage burning and didn't see much footage after that. So it wasn't known right away whether or not this launch was successful. However, after their report, it was also confirmed by the U.S. Joint Space Operations Center that they showed the SS-520 exceeding its orbital expectations, and that the rocket and the TRICOM-1R CubeSat were in a slightly higher orbit planned than the 200-kilometer orbit that they had reached there. So not only was this successful, it did better than initially planned. And the last time that we saw this rocket attempt to launch was from the SS-520-4 launch, which occurred last year on January 15th, 2017, and the second stage failed mid-flight. So this is very exciting that they were able to pull this off, and that the information has been confirmed that they were successfully able to place the upper stage and the CubeSat into orbit. So I really like to see on both sides of the scales of rocketry of having these really small nano-satellite launchers and then the really big launcher that hopefully will be debuting this week as well. So congratulations to all the people at JAXA who've made this project happen.
I just love how it kind of it rockets off the pad, and Destructor in the chat room, he said, and gone, just gone. Because it just exploded off that pad. That was crazy.
Oh, that's solid motors for you. They're pretty potent. So.
Oh, man. Thanks, Mike. Jared, tell me about something that we lost that we now found again.
Yeah, it's always nice to have something come back to you, especially if you lose it a really long time ago. And it's sort of the big surprise that's happened in the space science world this week, which is that a dead NASA mission is back, like some kind of orbital Lazarus coming back to us. And this mission is called the Imager for Magnetopause to Aurora Global Exploration Mission, and it's also known as IMAGE.
It's a mouthful.
Yes, a little bit. So I will call it IMAGE from here on out. It was launched from Vandenberg Air Force Base on March 25th in the year 2000, and it operated until December 2005 when they lost communication, and they expected a potential reboot to occur sometime in December of 2007. But it ended up yielding nothing as well, and the mission was officially declared dead and over. But lo and behold, last week, on January 24th, Scott Tilley, an amateur radio astronomer in British Columbia, happened upon a happy accident while observing the sky. He was actually hunting for signals from a potential payload that we've talked way too much about. And he ended up finding an unexpected signal. And he contacted NASA very quickly, who locked on it and found that the ID code on that signal is 166, which is the same as image's code. Now, the expected peak of signal and the oscillations from image rotating were present as well. And then this week on January 30th, the Johns Hopkins University Applied Physics Lab had a go, and they were receiving telemetry from image. Now, NASA has said they're going to continue to work to make sure that the signals are actually from image itself, which would make it officially official that it's not quite dead yet. But don't get your hopes up too far. The hardware and software for image is old enough that it's likely not around anymore. But that's not going to stop the engineers from attempting to what would be the next step after official confirmation that image is back, which is attempting to turn the science package on and then receiving useful data from it. Because image was, after all, a science mission. It was sent up to study the magnetosphere and its interaction with high-energy particles that lead to auroras. Now, its legacy was carried on by the magnetospheric multiscale mission, which is 4 spacecraft flying in formation to gather data. Now, if image is able to return scientific data, it will allow observations between the 2 missions in detail that we could only dream about. So that is really exciting. Then it's just suddenly turned right back on, and it's like, hey, I'm here. What are you guys up to? What have you been up to? And they actually went back in what we call pre-covery, where they looked at data from before, and image was actually broadcasting as early as October of 2016.
Oh, wow.
So it's only just now that somebody actually noticed.
Just because we happen to be looking at that particular area.
Because they were trying to find with it. So, yeah.
I love that, it's amateurs getting out there that, helped to kind of find it and bring that back to life. What were you going to say, Space Mike?
I also kind of love how this follows the law of the universe, that we didn't find it and reestablish contact with this thing until we'd already sent up all of the replacement satellites to replace this scientific mission. So you don't find what you've lost until you buy a replacement for it. Isn't that the rule of the universe?
Something like that.
And speaking of replacing things, Space Mike, what's happening on the station?
Yeah, there was so if you remember last week, we talked about a faulty hand at the space station, which is the latch end effector that is at the end of the Canadarm. And there was a planned spacewalk that Mark Vande Hei and Norishige Kanai were going to conduct this past Monday to replace that latch end effector. And that was canceled due to a software patch over this past weekend that got the new hand working properly. So Vande Hei and Kanai are going to go on another spacewalk on February 15th to bring the old hand that they were going to swap out back inside the station for an eventual return inside SpaceX's Dragon capsule. Meanwhile, the people you see on screen are Russian cosmonauts Alexander Misurkin and Anton Skaplerov, who floated outside the International Space Station on Friday and installed an upgraded electronics box for one of the high-gain communications antennas at the aft end of the Zvezda service module. Now, the spacewalk was expected to last a little over 6 hours, but the work took a little bit longer than expected, and Misurkin and Skaplerov finally returned into the Piers airlock and closed the hatch at a duration of 8 hours and 13 minutes, which officially made Friday's spacewalk the longest in history for Russia's space program and the 5th longest spacewalk ever. So that was kind of a happy little accident that they had after all of that hard work. Now, what they were doing, the electronics box that they replaced is used on the critical Lyra high-gain antenna that's used to transmit data between the station's Russian segment and Russian ground controllers near Moscow. And the cosmonauts, after they were able to replace it and untangle all of the different latches for it and all of the different wires and connections, they tossed the old Lyra electronics box overboard, so to speak, where it's going to be expected to burn up in the atmosphere in a couple of months. Now, after replacing the Lyra electronics box, and there he is tossing it over to the side right there.
I love it.
The ground control.
Space junk.
for a little while anyway.
Nice.
Now, after they replaced the new box, ground controllers actually had trouble rotating the antenna because the new box was getting snagged on old radar equipment. So that's what took so long. The cosmonauts had to troubleshoot and move around a lot of different wires and hardware to accommodate the new electronics box so that the antenna could rotate freely. So that was a successful spacewalk there, and I'm glad that the latch-end defector for the Canadarm was able to get fixed with a software patch, and that things should be able to continue moving forward. And the schedule for this year for the International Space Station is going to get really exciting near the end of this year. So all these little things right now are preparing for that. So we'll talk about that at a future date.
Yeah, I mean, I love that they still got to go outside and do that spacewalk, even though the Canadarm was fixed. It was still cool. They got to go outside, and we got all that cool footage. Like, that footage was amazing, and there was so much of it, which is really cool.
Yeah.
But Jared,
Yes.
tell me a little bit about some burps in space.
Yeah, occasionally there are burps in space, not just from astronauts, but from actual objects that are out in space. And these burps are related to black holes. And what's very cool about this is that when we look at large galaxies and even some low-mass galaxies, we often find a supermassive black hole at their core. And this is a black hole with a mass that is millions, if not billions of times that of our own sun. And they have an appetite for destruction, but that depends on what's around them. And they tend to also throw what they're feeding on around a bit as well. So a team led by researchers from the University of Colorado Boulder presented at the 231st meeting of the American Astronomical Society. And by the way, that's a yearly meeting. So yes, this was the 231st year that the American Astronomical Society has met. And they saw a supermassive black hole in a galaxy called SDSS J1354 plus 1327, doing the cosmic equivalent of a messy midnight run to the fridge. Now, there were two separate outflow events that were observed, and these are events where material comes close to the black hole. Some of it falls into the black hole, but some of it also gets flung out because it doesn't pass the event horizon, and it's moving fast enough that it can overcome that gravitational pull because it hasn't crossed that point of no return. So they found one that occurred quite a while ago and was sort of dissipating out into space, and then they found another one showing that there was recent activity. So we had two burps, if you will, that came from this black hole. Now, they used additional observation from the Chandra X-ray telescope, Hubble Space Telescope, and the Keck Telescope in Hawaii, and they found that a very large cone of material was extending about 30,000 light years from the bulge of the galaxy. Now, because the gas is ionized, it's really energetic, we can determine that it encountered the black hole about 100,000 years ago. And then coming from the north of the black hole was a shock wave of gas, and that was only about 3,000 light years away from it. So, and a companion galaxy close to J1354 likely interacted during the past. So what happened is that as the galaxies sort of went past each other, some gas from the companion galaxy likely was sent on a plunge of doom to be the black hole snack. Now, this actually isn't a unique structure in our universe. Our own Milky Way galaxy has the leftovers of a snack from our own supermassive black hole, Sagittarius A star, and it had it quite a long time ago. Now, these two bubbles of gas extend above and below the plane of the Milky Way, and that indicates that Sagittarius A star likely had its snack about 7.5 million years ago. Now, both our own supermassive black hole in the Milky Way and the supermassive black hole in J354 are what the astrophysicist Dr. Julie Comerford calls currently in a galactic food coma, where both of them are inactive because there's basically no material around them to fall in. But, you know, we monitor especially Sagittarius A star, our supermassive black hole in the Milky Way, and we have a very good lock on it, and we look at it all the time in order to see if there's any flare-ups or things that fall in to that black hole, and we're just keeping a very close eye on it because when we do that, we learn a lot more, and turns out black holes very far away across the universe work almost exactly like the black holes that we have here in our own Milky Way. So there you go, more proof that physics works exactly the same throughout the universe.
It's always good to be getting more and more data. So,
yes,
yeah.
Never enough data.
Never, ever.
So,
all right, that's all the news that we have for you today. So we're going to take a quick break, and when we come back, we're going to be interviewing Gilmour Space Technology. So stay tuned. We'll be right back.
occasion. This girl's a fascination, and nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, through the heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back to Tomorrow. Now, before we get into our interview today, I want to give a huge shout out to all of the citizens of tomorrow to help make this show possible. So we've got our Escape Velocity citizens. These are the people that give us $10 per episode or $30 per month on Minds.com. And we also have our Orbital subscribers. These are the people that give us, how much do they give us? A lot. They give us $5 per episode on Patreon, or they give us $15 per month on makersupport.com. And if you'd like to go help out the shows of tomorrow as well, you can head over to patreon.com or makersupport.com/TMRO. Cool. So today we have James from Gilmour Space Technologies with us. And James, thank you so much for coming and being on the show today for us.
And hi, everyone.
Cool. So I think to start off, the first thing that our viewers might want to be aware of is I don't think a lot of people might have heard of Gilmour Space Technologies because you're actually an Australian company, right?
Yes, so we're based in the land down under. For those of you who don't know us, Gilmour Space Technologies is a relatively new space engineering company. My brother and I started this venture in 2012. And we're based in Queensland, Australia, and we're developing and building a new breed of low-cost hybrid rocket launch vehicles.
That's awesome. So the vehicles that you're going to be launching, what kind of market are you trying to aim to fill there?
So, look, we're looking to have two, commercial products. One is a sounding rocket. Please, if your viewers wish, jump online. You'll see our first rocket that we launched successfully in 2006.
Is that the Raster rocket?
We did that with the Raster rocket.
Yeah,
so
we've got
that
a video
was,
of that, I think. This one here, I think, is our...
So you're just seeing that now. So that was launched on the 22nd of July in 2016 to a small altitude. Essentially, that was a technology demonstrator in an attempt for us to look at some venture capital support. We did that with a small team of just 3 headcount. Today, we've got a staff of about 30. Comprising majority of engineers, and we also have operations based in Singapore. But to get back to your question, Lisa, so our first kind of commercial product will be a sounding rocket, and some other footage you might have is of the motor that we just tested in the 22nd of December last year. So that was quite a significant achievement for our company. We achieved 45 kilonewtons of thrust. And I was hoping to have some more footage for you guys, but we've delayed our test, and we're looking at Wednesday of this week to perform a high pressure test that we expect to see about 70 kilonewtons of thrust. And essentially that will be our motor for our sounding rocket. And then after that, we're looking to develop a small launch vehicle to low Earth orbit. And our mantra, part of our reason is to design for cost and look at providing the cheapest orbital insertion vehicle around.
So the two programs that you have the, I believe it's called the aerial rocket, that's the sounding rocket, and then the orbital rocket.
That's the sounding rocket.
That's the ERIS program, is that right?
Yes, that's right.
Awesome. Why those names? Why did you pick those?
Well, look, I mean, those were just names based from Greek goddess, and we just thought that was a nice name that was going to respond favourably to the marketplace. However, that is also subject to change, and we might be looking to put out a bit of a competition with regards to engagement of STEM in Australia to look at some of the naming rights for those future launch vehicles. So something to keep an eye out for.
Yeah, that's a really cool idea. Hopefully I can get involved in that too, being Australian myself.
I hope so.
You guys actually do a lot of outreach, don't you? You had a STEM outreach program for school kids, is that right?
Yeah, so to take you and your listeners a step back, I guess why we looked at a space or space technology, my brother and I, it started with Burt Rutan and Scale Composites after them winning the Lunar X Prize. We saw that as a bit of a shift in the market, and we're calling that a space renaissance, spurred on by a number of people that you and your constituents are well aware of. James Cameron, Bob Bigelow, Elon Musk, Richard Branson, who are all successful businessmen in their own right, who are putting vast sums of money into space technology. And we always wanted to build rockets, but we knew it was going to be a very expensive exercise, and we thought that we could generate some revenue with a space camp. So my brother and I think it was in 2010, went to Huntsville, Alabama, and performed in the adult space camp. And while that was great, we thought that we could do a better job. And so started what was the initiative called Spaceflight Academy. And essentially that was astronaut training as real as it gets. It was really for anybody that was 9 to 99. We had high fidelity mock-ups and simulators. We had a 6 degree of freedom motion simulator platform onto a reusable launch vehicle, which was a pretty cool one of its kind, particularly in Australia. A 2 degree of freedom full size capsule. And a whole bunch of other multi-access trainers, wall climbs and stuff. And we did that for about 9 months. Mainly with schools and whatnot from the local catchment, but we also saw their travel domestically from Melbourne, Sydney, and even Perth, which was good. But that helped with some of our exposure within the market, and upon them receiving $5 million in venture capital to support the rockets, we have put that on hold.
So as well as giving you exposure and leading to you guys getting investment, one thing I don't think people realized about your Spaceflight Academy is that you didn't just buy all of those simulation equipment and simulators, you actually built them, right?
Yes. So one problem we encountered early on was that it was very hard to find anybody that had the capability to build some of our replicas and our mock-ups. So we originally started the company with the intent to design and build and fabricate all the high-fidelity replicas and mock-ups. So pretty cool, but a real shame for me, because they are sitting in our workshop gathering dust while we're looking at brokering local governments in order to see Spaceflight Academy come back to fruition.
Well, I mean, I hope it comes back as well, because I'd actually like to go and try out the simulators for myself, but we'll see what happens. Let's go back to the rockets that you guys are building. What kind of technology is going to set apart the rockets that you're making compared to the other rockets that we're starting to see come online?
Sure. So unlike most other rocket companies which use liquid rocket engines, they bring a lot of complexity and what I think is a lot of problems attributed to rocket propulsion. Ours is a hybrid rocket, and which is much simpler, less complex, and less explosive, and very much a green motor. So for some of your constituents who probably don't know what a hybrid rocket is, but they probably do, it's a mix of both a liquid and a solid. And we've demonstrated over 20 test fires from diameters of 7 centimetre, 9 centimetre, 15 centimetre, and just recently a 46 centimetre hybrid rocket motor.
And the 46 centimetre hybrid rocket motor test firing that you were doing, is that the one that you just test fired a month or two ago?
Yeah, so our first test was on the 22nd of December. So that is going to be the backbone for the sounding rocket campaign.
That's awesome. I think we've got some footage here that we're going to show. So can you talk about what's happening in this footage?
Yeah, sure. The test and verification of our BEM ballistic evaluation motor. So that was a 15 centimetre configuration. The one there is, the one in the screen now is the test of the 46 centimetre motor. So this is from a hybrid rocket, and that white part that you see there is actually the solid combustion chamber that we use 3D printing to reduce and overcome some of the legacy issues associated with hybrid rockets in the past.
So are you 3D printing the engine itself, or are you 3D printing the engine and the fuel? Because you guys can 3D print fuel as well, right?
Well, look, we, could 3D print all of it, but I think we're still a long way away from that. So essentially, 3D printing takes its place in the full fuel component of the motor, and it's still quite a long and laborious process, but it's overcome some of the issues associated with hybrid rockets, such as slumping. So we're really excited, and we think that we've got what it takes to be a real propulsion game.
Cool. The other thing I wanted to ask you guys about was when do you foresee this program coming online? Like, especially the orbital campaign that you'll be pursuing. What's your kind of timeline for all of this?
Well, timelines in rocketry, as Mike already knows, is very speculatory in nature. There are a number and a myriad of complex, both internal and external factors that affect it. And look, I mean, subject to regulatory approval, that large motor that you saw tested, we're hoping to launch that mid this year, and that will be to an altitude of about 70 Ks. It does have the ability to go higher, but in Australia we have some onerous and draconian rules associated with rockets, and once you go over 100 Ks, you trigger a lot of red tape and a lot of insurance that I don't think is fit for purpose. So we're looking to fly under the radar, so to speak. And we're also in the process of securing a launch range. And with that in mind, we'd like to start commercializing sounding rockets by 2019. We've already got some indicative letters of support and intent. So essentially, we're not like the you might see, we're going to show and prove ourselves. And once we verify our technology, that's going to give us our confidence for us to move forward and engage with the our customers that we've been speaking with.
So you're flying under the radar for now, but in the future, do you think you might have plans to work with or get support from the Australian Space Agency? Because we have a question from the chat room from Astro YYZ, who is asking, will you work with the new Australian Space Agency, the one that got announced in September of 2017 at the IAC conference in Adelaide?
Oh, look, good question, without a doubt. I'm also a big advocate, and I've been lobbying the government and the community for an Australian Space Agency for quite some time. I was part of, I'm an advisor to the Space Industry Association of Australia, of drafting some of the law papers for cabinet submission. And yeah, look, I mean, just to give you guys an update on that, the Arthur Senadinos announced a review of Australian space capability, and there was an expert review group that went around the country engaging with and industry and government looking at Australian space capability, and they have earmarked a report from those findings in March this year, which is quite exciting. And look, the establishment of an agency like that will take some time, and we're looking to ensure that there is a favourable landscape for companies like mine who are looking to create an Indigenous launch capability, and also support some of the great and innovative startup and getting established satellite manufacturer companies particularly in Adelaide, who very much know about Lisa.
Yeah, and I think here at Tomorrow we kind of have an all ships ride with the tide mentality that, you know, the more of a friendly ecosystem we have for space all around the world, it kind of helps everyone. So it's looking up for Australia to kind of finally get in the space game, and that's gonna have effects around the world, I think, especially if we can get, you know, small sat launches going as well.
Oh, look, 100%. I've got a philosophy that is deep with me, and that is, if you want to go fast, go by yourself, but if you want to go far, go together. And look, it might be a bit easier if we were to move and, you know, maybe start up in another country that's favourable to a launch provider, but we're not. I was born in Australia, and I'm going to do whatever I can to ensure that we can provide an Indigenous launch capability. And I think that the biggest hurdle that we have to overcome as a space community is the education around some of the stuff that is happening, and it has the potential to happen both domestically and abroad. And I think that's a major element.
Are you planning to launch from Australia too, or will you be utilising worldwide launch facilities?
Oh, well, look, I mean, we'll here in Kennedy 2 years ago, looking at launch options and whatnot. There still might be an opportunity for us to launch from the Cape, which is quite exciting. They even said that we could assemble some of our componentry in the old VAB, which would just be, you know, amazing. But you know, I think there are some synergies to be had, particularly with orbital insertion from Australia, both to the north of the country and to the south of the country.
No, that's all good. So I might just finish off with one last question, just about the kind of price point that you see your launches coming at, and how that might enable, you know, the small sat kind of revolution and help open access to space for small satellites.
The good old price point discussion in launch vehicles. Yeah, look, I mean, our mantra is to design for cost. If you look at our factors of production with regards to hybrid rockets, they are traditionally safer. We don't need a turbo pump, or we don't need to cryogenically store our fuel. So that always helps when you're trying to mitigate costs. Hydrogen peroxide.
Right, cool.
So you can store that at you need appropriate PPE, which is personal protective equipment and whatnot. But it's not as dangerous or as toxic as some fuels in liquids or solids. And speaking of price, there's been a lot of if you want to talk about the heavy end of the scale, we're looking at about a $23,000 to $38,000 per kilogram for a max payload of about 400 kilograms. And we think that we can achieve that because of some of, like I mentioned, factors of production with hybrid rockets. And the other thing I would like to mention is with some of the other established companies, they have huge headcount. You're looking at over 400, 500 people for a vehicle that hasn't even launched that, and that's the
bandwidth in Australia is something to be desired. So this connection is coming across an ocean. Fingers crossed we can get James back. And we've dropped out.
And it's gone.
It's gone. Well, I think what we might do is we might wrap that interview up there. And what we're going to do is take a quick break. And when we come back, we're going to have our questions and comments from last week's show. So stay tuned. We'll be right back.
Science. It both draws us together and tears us apart. Brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
And welcome back to Tomorrow. Now, before we get into our questions and comments from last week's show, we'd love to give a huge shout out and thank you to all of the supporters of Tomorrow. These are our crowdfunding supporters, our Escape Velocity citizens, and these are the people that give us $10 per episode on Patreon or $30 per month on Maker Support. But we also have our Orbital citizens who contribute $5 per episode on Patreon or $15 per month on Maker Support. And we also have our Suborbital citizens who give us $2.50 per episode on Patreon or $5 per month on Maker Support. And they get their name in the show during the third segment, exclusive access to Patreon-only hangouts, and much, much more as well. So if you'd like to help crowdfund the shows of tomorrow, you can head over to patreon.com or makersupport.com/TMRO. All right, and before we do get into comments and questions from last week's show, we also want to give a huge shout out to the First to the Moon Kickstarter campaign, which is the little promo that you just saw in that ad break there. They're going to be doing some great work, right, Jared?
Yeah, I really hope that they can make their Kickstarter because Apollo 8 was an incredible mission and came at a really tumultuous time in American history too. So it was very important culturally in that time period. So I really hope that they make it on that.
They've got a few more days left in their campaign, but they're not quite at their goal yet. So if you have the ability to, and only if you do have the ability, and you think it's a great thing that you'd like to support, we recommend heading over to Kickstarter and looking up First to the Moon. It's going to be a great movie, and we wish them all the success in their crowdfunding campaign and in the production of that movie.
Yeah.
All right, so our questions and comments from last week's show. Last week we talked about SpaceX's Falcon Heavy. That was Orbit 11.04. And our first comment today comes off of Reddit, and it is from Cap MSFC. And Cap MSFC says, the Ariane 5 launch anomaly is a way bigger deal than you made it seem in the show. It was completely out of the flight corridor the whole time and flew over populated areas. The SRBs, solid rocket boosters, and core stage were dropped way outside of their exclusion zones. This flight was a public hazard and should have been terminated as soon as it pitched over on the wrong trajectory. It's a dumb luck of compounding mistakes that the mission is only a partial failure, with both sats able to make up for the inclination difference.
Mm-hmm. Yeah, it was a really big problem after it happened. But I guess to kind of qualify this comment came 4 days after our show, where we talked about it, which when we did our show, this was not a known thing at the moment. We didn't actually know what the trajectory was of the Ariane 5. We didn't realize that it had crossed over populated areas as it was doing that. So we legit did not know this. And of course, it's kind of tough to update a show when you've done it.
Yeah.
So, yeah.
And to the idea, too, that it should have been terminated as soon as they figured out that it was in the wrong trajectory. They didn't know that it was in the wrong trajectory until they reestablished contact with the upper stage and satellites after the upper stage had already finished its firing and the satellites had separated. So to be honest, there wasn't really a way to even terminate the launch, which I agree, they probably should have done that, having launching and separating parts of it overpopulated areas, but they didn't even have the capability to do so. So yes, this was very serious, and one other thing that I think, NASA even is going to be involved with the investigation of this mishap, especially considering that the James Webb Space Telescope is supposed to be launching on Ariane 5 soon. So there's going to be a lot of serious work to figure out exactly what this problem was. And I still haven't gotten any updates, though, as to whether or not the rest of the Ariane 5s, at least before James Webb, are going to continue launching as planned, or if they're going to ground the fleet for a little while. What was your point, though, that you were going to say, Lisa?
Well, the two problems I was going to say is, first of all, that they didn't know it was on the wrong trajectory. Like, how can you not know where your rocket is? Like, that to me is crazy pants. Like, and then the second one is that, like, even if they had have terminated it when it was flying over those people, if they had have broke it up, like, above people, then wouldn't the debris rain down on people like a China launch? Like, isn't that dangerous as well?
Yeah, so that's actually one of the things where they're talking about too, not just necessarily with this, but also with that claim made by the Air Force a couple weeks ago, which is that they're going to be able to do polar launches out of Kennedy Space Center, because that has the rocket, hug Florida and go over places like Bermuda and Cuba in order to do that. So yeah, it is kind of one of those things where if it is over a populated area, that's a very tough decision to make as to whether you terminate the flight or not. Because if it's flying nominally, like correct attitude, and it's just on the wrong path, you may not want to terminate it because the rocket may continue downrange, so then you can send it to a safe place to terminate it. But terminating a rocket is really a game time decision. That's a decision that you make not 60 seconds before you terminate it. You have to, it's sort of like a on the spot kind of determination with it. So
yeah, and in our chat room, Therion said that they did know that the trajectory was wrong, actually, and that they decided not to destroy the rocket because the debris would have fallen on the populated areas.
Yeah, and I just want to point out that Ariane Space knew the trajectory was wrong. We didn't know until a couple days after the failure that happened. So there was really no way for anyone in the public to know that had occurred. Sure, you can look at like screens of stuff and everything, but there was definitely, if you look at you can look at screenshots of the trajectory screens in mission control, and it is definitely not on the correct trajectory, but there's not enough detail in those images to tell whether it was actually over a populated area or not. That's why we had to wait until later to find out about that. So yeah. So
all right, I think we've talked that one to death a little bit.
Yeah. So
although
it's the new Zuma. So
Mike, what were you going to say?
Well, go ahead and get to the next comment, and you'll see what I mean.
Okay, so the next comment comes off of YouTube, and it's from SP123 100. And they say that I found it concerning how the Ariane 5 launch commentary just carried on reading out the milestones. Although I'm sure that they just show stock footage of booster and fairing separations, I believed Ariane Space were a little more transparent, or at least they present themselves as such. I might have expected this of a Russian or Chinese launch, but I feel that Ariane Space have lost a considerable amount of webcast credibility over this. SpaceX have shown that sharing failure is almost or as important as sharing success.
Yeah.
I'll agree that I found it concerning as well, but I mean, we might not necessarily be able to blame the webcast announcer because they were just doing their job and continuing things forward as they thought that they should have been. So once that person was informed of the problem, they said so, and they stopped the webcast shortly after and had the whole statement by Stefan Israel. So as soon as that person who was giving out those calls was informed, then yeah, they corrected themselves. But I also found that it was pretty kind of concerning as well, even though the data showed the things that they had lost contact with it and that they weren't getting telemetry. So
yeah.
I think it's important to be kind of like, you don't want to mislead people, right? Like, you want to show them the webcast, you want to get them excited about space, but you also don't want to feel like, that you're just kind of pushing this, everything is perfect, we're going completely nominally message when it's obvious like that you're not. So.
Yeah, there's been a tremendous amount of hindsight as 2020 about this whole situation as it was happening, or post after it had happened. So, yeah, it's yeah. Go ahead, Mike.
And all I'm just saying is let's try to give them the benefit of the doubt that they weren't trying to necessarily mislead us on purpose.
Yeah, of course.
Yeah, they might have been getting ratty data for all we knew. So we don't have the actual data in front of us. So I feel like I can't make a determination as to whether they were intentionally or they just genuinely didn't actually know at that time. So because we don't know what the quality of the data is. Ariane Space does, and they're probably not going to let you see that because that's how the aerospace industry works. So you don't just throw your data out there for everybody to take a look at in most cases. So yeah, who knows? So it's just another one that will go out into the aether of the universe, and we'll find out probably 50 years down the road what actually happened. So.
Well, fingers crossed. They've got their data, they look at it, they work out what went wrong, and they fix it, and we see Ariane launches continuing long into the future. So all the best to them, and good luck with their investigations.
Yeah.
So our next comment comes off of YouTube. It's from Louis Hen. This will also be the first time a private space company sends a payload beyond GTO, and they're referring to Falcon Heavy here.
Mm-hmm. Yeah.
Now, I don't know if this is correct.
Isn't that exciting?
Because I was doing some Googling, and Falcon 9 launched Discover to L1, right?
Yes.
Which is beyond GTO.
Yes. But I think in this case they're talking about a private company sending a private payload beyond GTO. And I actually don't think that's correct entirely, because there were several... There have been several geostationary communication satellites that were put in the incorrect orbit, and the teams that were flying them ended up flying them around the moon in order to put them into the correct orbits.
Oh, cool.
So I don't know if this is entirely true, but I'm not sure if I'm entirely correct in questioning that either. I know the comments will definitely correct us if something like that happens. But yeah, I don't know.
What's going to be the first one to send something to a near Mars orbit, right?
Yeah, Martian flyby for sure.
Yeah, this would definitely be the first private thing sent on escape velocity for sure. So yeah. So, but yeah, I don't.
If it gets there successfully.
Yeah, I don't know about GTO, but definitely a heliocentric orbit on purpose. Yes. So.
Well, fingers crossed it launches. Currently slated for Tuesday, so all the best to SpaceX, and hopefully.
Good luck.
It'll go successfully, and we can make more comments on that next week. All right.
Yeah,
the next comment comes off of Reddit. It's from Kubrick is my co-pilot, who says, ultimately, the only way to improve safety is to fly. Too much emphasis on modeling means that all you're doing is building a pyramid of assumptions, some of which evaporate the moment they make contact with reality. Ironically, it will be the organizations and institutions willing to take risks that will advance safety the quickest. Those who demand guarantees up front will before they will even try, will be left in the dust.
Yeah, you gotta fly in order to make sure things are gonna work. So, and it's important to fly. How would I put it in flight testing? It's important to be methodical with your progress that you do. So, so something like the space shuttle with STS-1, the first flight to Columbia, we're going to stick a crew on it and go with it. I don't know if that would be a good way to go about things nowadays.
Yeah.
You probably get away with that back then because of the culture that was around at that time, which is a fascinating thing if you ever want to study the culture of the safety of spaceflight, especially at NASA in the early 80s. It's fantastic to understand. It's an important point, but you also have to err on the side of caution because if you start losing payloads, you tend to also start losing customers. And you also don't want to lose your customers as well, especially like your actual physical customers themselves. So,
living, breathing ones.
Yeah.
So, space
And
Kyle.
ironically, I think it's funny that you said that sort of thing wouldn't happen today. The jury's still out whether or not there's going to be a crew on Exploration Mission 1, the first flight of Orion and SLS together. So,
as far as I understand, Space Mike, the cost to accelerate the safety for Exploration Mission 1 has pretty much ruled that out. So. At least
the cost, yes, that has definitely was going to be way too much, but it hasn't officially been decided yet, as far as I knew. I could be very wrong on that.
Yeah, I might be wrong too. So
still, the fact that they were even considering it in today's day and age, especially since Orion has a way lower safety standard than even SpaceX and Boeing Starliner does. So it's just ironic.
Space Cull in the chat says, "I'm fine as long as it explodes. I'm fine if it explodes as long as they learn something." This must be in relation to Falcon Heavy, but I guess it applies to crewed vehicles as well. As long as they learn something, I just hope it explodes after it clears the launch tower.
Yeah, that works pretty good in flight testing. Not so much in like actual
and people
stuff. And yeah, like people, you tend to not want your thing to blow up.
Let's not have it explode.
So yeah.
All right, our next comment comes off of YouTube, and it's from Rabinda Mishra, who says, "I wonder if NASA could make their deep space gateway design flexible enough that it can be assembled using Falcon Heavy. Same goes for their lunar plans. Imagine how much more can be achieved than if we had to wait for SLS to fly, which would be never. No, kidding. SLS can still be built for deep space missions like Europa Clipper, Uranus and Neptune orbiters, etc."
Yeah, I mean,
go
for it, Space Mike.
I think so. I think that they, the way that, and of course the design hasn't been finalized yet, but the way that the designs are moving forward so far is definitely flexible enough that at least some of the pieces, maybe not all of the pieces, but a lot of the pieces could be launched on Falcon Heavy. But even with some of our international partners, I mean, there's some Japanese pieces that are going to be launched on H2A or the H5, whichever comes online first. And even with our Russian partners, they're planning on launching their pieces of hardware either on Proton or an Angara 5. So why not? Why not Falcon Heavy in that mix as well? We don't have to launch all of our pieces with SLS. The whole thing with the architecture right now is launching a piece of architecture for the Deep Space Gateway with an Orion capsule and maybe even like a logistics module full of cargo or something like that, all in one launch. You could send just the piece of architecture itself, in a single launch on a Falcon Heavy, depending on which piece we're talking about. So we could go into that quite a bit and go over like all the weights requirements and stuff that exists so far. But this is still a work in progress. But I don't see why Falcon Heavy couldn't be used for a lot of it.
Do you think that if we allowed those things that are supposed to fly on SLS to fly on Falcon Heavy, should we start launching them on Delta IV Heavies and stuff as well? Because I guess you don't want to kind of favor SpaceX, although they are cheaper, but like shouldn't it go to all US launch providers and not just kind of SpaceX, so we're showing favoritism? Stuff
like that kind of depends on how far along you are in the development of your payload. After the Ariane 5 anomaly, I guess we're going to call it, there was a huge voice that was like, switch James Webb to Falcon Heavy, switch James Webb to Falcon Heavy. And it's like, that's not how that works. You know, you design your payload to deal with the environment that your launcher is going to be subjecting it to, both in like your loads that you're going to have, your acoustical issues and things like that, the vibration environment and things like that. So it's really dependent upon where you are in the development of your vehicle, or your payload. So if you're in something like as far along as the James Webb is, where we're going to be hopefully launching it next year, sorry, you know, we're too far along in development. But something like Europa Clipper, which is being developed at the Jet Propulsion Laboratory here in Pasadena, it's early on in stages of development. It's being baselined for the Space Launch System, but they also do have the ability with that mission to put it on a Evolved Expendable Launch Vehicle. With that there, I can't recall ever seeing them talking about putting it on a Falcon 9 or a Falcon Heavy, and that probably has to do with certifications or something well beyond my current understanding. But yeah, you can't just like switch a payload because you feel like you want to switch it, or because, hey, you know, it's like going to two different car dealerships and saying, you're going to give me this for this, and then running to the other one and saying, hey, they're going to give me this for this. You want to cut it lower, and they drop it, and you run back, hey, you want to give me lower than what they're doing?
Just negotiating.
Like that, yeah, it's a little difficult to kind of negotiate, simply because a lot of the times the design work says, the design work that you start with is baselined for a certain launcher, and that launcher has characteristics about it that are different from every other launcher. It's a wholly unique thing. So yeah, it's kind of difficult to do that. It would be so cool to have like a modular system that would allow us to plug and play on all these different rockets depending upon what we need, but you know.
There's a business idea, guys. Someone go and start the payload adapter company of tomorrow.
I have an idea.
But you know what? It raises a good point. You know, if you
Can't
say
wait to
that
be a used rocket salesman.
let's send up the Deep Space Gateway on like Heavy instead of SLS, then you get this question that Jaded Animal from Twitch says in the chat room. You've got to use SLS because otherwise, if you don't, people will start to ask inconvenient questions. Like, why do we need SLS at all then if you can put all its payloads on Falcon Heavy, right? So you've got to kind of have missions put in there to go on SLS and Europa Clipper as well. So that SLS has a reason to exist, right?
Yeah.
But that's kind of sad.
Yeah, and there might be advantages to using SLS as well, so that we don't know about yet, you know, because not everything is with the upper stage that's being worked on beyond the one that they are currently looking at putting on it. I think it's called the Evolved Upper Stage, Space Mike?
Yeah, and that one is a weird story too because they already developed the J2X engine for it. But shelved it and put everything on hold with the program in favor of the upper stages that they're going to use first on the SLS program. And so that's probably going to have to be completely restarted if they're even still planning on using the J2X engine for stuff that would like be heading to, you know, Mars or beyond. So
Gotcha. Yeah.
We'll see.
Man, this stuff's complicated.
It's spaceflight, right?
Man.
Space is complicated. All right, that's our last comment. So before we head off today, we want to give a very big thank you to our ground support patrons. These are the people that give us $1 per episode on Patreon or $1 per month on makersupport.com. They get their name in the show during the third segment, as well as a few other rewards. So if you would like to become a crowdfunder of tomorrow, head on over to patreon.com or makersupport.com/TMRO. All right, everyone, that's our show. After Dark is up next, and yeah, we'll see you next week. Bye-bye.